Okay, let's start with the basics. Backend development is all about what happens after a user interacts with a website or app. It's the engine room. It handles things like storing information, making sure users are who they say they are, and ensuring everything runs smoothly behind the scenes. Basically, without backend development, your front end would be just an empty shell. Okay, let's talk about what a backend developer actually does. Essentially, they are responsible for everything that happens behind the scenes when you use an app or website. They build and maintain the servers, databases, and API, all those things you don't see but are super important. A big part of the job is managing data, creating the pathways for information to flow between different parts of the application, ensuring everything runs smoothly and securely, and making sure it can handle lots and lots of users. They work with a bunch of cool technologies like Python, JavaScript, and various databases. Really, it's a diverse field. Okay, so let's talk about how backend systems are built. It all starts with something called the client-server architecture. Basically, imagine you're using an app or website. That's the client. The client is what you see and interact with directly. It displays information, takes your input, and makes requests. Then there's the server, which is like a powerful computer system. It handles all the behind-the-scenes work, processing those requests, managing data, and delivering everything the client needs. It's a simple process. You ask for something, the request, the server figures out what to do, and then sends back your answer. Okay, let's talk about designing good RESTful API. At their core, these principles are really important for building scalable and maintainable backends. You've got client-server architecture, clear division of responsibilities between the front end and the back end. Statelessness means each request contains everything it needs, so the server doesn't have to remember you from one request to the next. Caching is key for performance. Responses should be designed to be cached where possible. Layered systems allow for scaling and flexibility. And finally, a uniform interface using standard HTTP methods like get, post, put, patch, and delete consistently makes your API much easier to understand and use. Okay, let's talk about how backend developers communicate with servers. It all boils down to HTTP methods. Think of these as commands that tell the server what you want it to do. Get is like asking for something, like show me this user's profile. Post is used when you're sending new information, such as creating a new account. Put replaces an entire record, while patch only changes bits and pieces. And delete? That's removing something completely. Understanding these methods is crucial for building robust backend applications. Okay, let's talk about how your backend communicates with clients using HTTP status codes. These are like little messages from the server, telling you if everything went smoothly or if something needs fixing. A 200 OK means all good, the request was a success. If you get a 400 bad request, it's usually because there's something wrong with how you built your request to the backend. Other codes like 400 when unauthorized and 500 internal server error point to problems that need attention, authentication failures or server errors respectively. They're really important for debugging and building reliable apps. Okay, so when we're building backends, we need a way to send data between the server and the client. JSON and XML are two popular formats for doing just that. JSON is super easy to read. It's like organized key-value pairs and JavaScript loves it. It's really great for things like user profiles or API responses. Then there's XML, which uses tags to wrap up data. Think of it as a more structured way to organize information, especially useful for configuration files or when you need strong validation. Both have their place. JSON is often preferred for its simplicity and speed, but XML can be better if you need really detailed control over the structure. Okay, let's talk about WebSockets. They are a really important tool for backend developers when you need to build applications that require real-time updates. Think of it like this: instead of constantly asking the server for new information, which can be slow and inefficient, WebSockets create a persistent connection. It's like a direct line between your client, like a web browser or mobile app, and your server. allowing them to send data back and forth instantly. This is super beneficial for things like live chat, online games, or any application where you need users to see changes happening immediately. Basically, WebSockets are all about speed and efficiency when it comes to real-time communication. Okay, so let's talk about keeping our backend app secure. We're going to cover authentication and authorization, two really important concepts for any developer. First up is authentication. This is all about verifying who the user actually is. Think of it as checking their ID. There are lots of ways we can do this, from using a standard username and password to letting them log in through services like Google or Facebook. And for extra security, we often use multi-factor authentication, which adds an additional step beyond just a password. Now, once we've confirmed who the user is, that's authentication, we need to figure out what they are allowed to do. That's where authorization comes in. Authorization determines access rights essentially. What can this person do? We can control this using things like roles, like admin or user, and also by looking at specific attributes about the user and the data they're trying to access. Okay, let's talk about session-based authentication. It's a really important concept for backend developers. Basically, when a user logs in, instead of constantly sending their password with every request which isn't secure, the server creates a unique session for them. It generates a random ID, stores the ID along with some information about the user and the server asterisk, and sends that ID back to the browser, usually as a cookie. Every time the user makes another request after logging in, they include the session ID. The server then looks up that ID and can verify if the user is still logged in and what their permissions are. It's like a secret handshake between the client and the server, keeping things secure without needing to repeat the login process every single time. Okay, let's talk about JWT, that's JSON Web Token. It's a super common way to secure backend applications, particularly API. Think of it like a digital passport for your users. Unlike the older method of storing session data on the server, JWT are stateless, which makes them really efficient. Essentially, when someone logs in, we create this token, a little piece of information packed with details about the user, and send it to their device. Then, every time they want to access something protected, they include that token in their request. The server checks the token's signature, and if everything's valid, grants them access. Pretty clever, right? Okay, so we're talking about OAuth 2.0 and OpenID Connect. They are super important for building secure backend systems. OAuth 2.0 is basically a way to let apps access your stuff without you having to give them your password directly. It's like giving an app permission to act on your behalf. Then, OpenID Connect builds on top of that, specifically adding a layer to verify the user actually is confirming their identity. Think of it as OAuth 2.0 with an added authentication step. We'll break down some key players: the resource owner, the client, the app, the authorization server where you get the tokens, and the resource server where your data lives. Okay, let's talk about how we keep passwords safe. Storing them directly in a database is like leaving the keys to your house out in the open, a huge risk. So, what do? We use hashing and salting. Hashing turns passwords into unique fingerprints, making it extremely difficult for an attacker to figure out the original password if they get their hands on the hash. But hashing alone isn't enough. We add a salt, which is basically random data before we hash. This ensures that even if two users have the same password, their hashes will be completely different, thwarting rainbow table attacks. We combine the salt and password, hash it, and then store both the hash and the salt in our database. It's a really important step to protect user data. Okay, so let's talk about cross-origin resource sharing. Basically, your website can't just jump over to another domain and grab data without permission. The browser has this thing called the same origin policy that blocks it for security reasons. Think of it like a gatekeeper. But sometimes you need to get data from other sites, so CORS lets servers tell the browser which origins are okay to talk to them. It's all about controlled access and keeping things safe. Okay, let's talk about making sure the data coming into our backend is safe and reliable. We call this input validation and sanitization. Validation is all about confirming that we're getting the *right* kind of data, the right type, within a reasonable range, and in the correct format. Think of it like checking someone's ID to make sure they are who they say they are. Then, sanitization goes a step further. It's the process of cleaning up the data we receive by removing or modifying potentially harmful characters. This helps prevent things like XSS attacks where hackers could inject malicious scripts into our website, and also protects us from SQL injection vulnerabilities, which can allow them to manipulate our database. Okay, let's talk about databases, specifically which ones backend developers use most often. We've got three big players: MySQL, PostgreSQL, and MS SQL Server. MySQL is super popular because it's open source and really easy to get started with, making it a good choice for many web apps. Then there's PostgreSQL, which is known for being incredibly reliable and really good at handling complex data. And finally, we have MS SQL Server, that's Microsoft's database system, often used when you're building applications on the NET platform. Okay, let's dive into the world of NoSQL databases. We're going to look at three key players: MongoDB, Redis, and Cassandra. MongoDB is a really flexible option. It stores your information in JSON-like documents, making it super adaptable for things like websites or catalogs where data structures can change easily. Then we have Redis, which is incredibly fast because it keeps data in memory. Think of it as a super speedy shortcut to frequently accessed information. Finally, Cassandra shines when you're dealing with huge amounts of data like social media feeds or sensor readings and need to make sure everything stays available and responsive. Okay, let's talk about making your database queries super fast. We're going to cover database indexes. Think of them like the index in a book. They help you find information quickly without having to read every single page. Indexes are data structures that speed up searches. They're really important because they reduce the time it takes to retrieve data and lessen hard drive access. There are different types of indexes, like B-tree indexes, which are great for searching, and hash indexes for equality checks. Beyond just indexing, query optimization means looking at how your database is executing a query and rewriting it if needed to be more efficient. It's about finding the best balance between speed and right performance. Remember, adding too many indexes can actually slow things down when you're inserting or updating data. Okay, let's talk about how databases handle data changes. We'll start with ACID, that's atomicity, consistency, isolation, and durability. Think of it like a guarantee. If a transaction doesn't complete entirely, nothing changes. Then we have base availability, scalability, eventual consistency, and baseline. This is often used in NoSQL databases where speed and availability are more important than having perfectly up-to-the-second data everywhere. It's all about balancing how consistent your system needs to be with how well it performs under pressure. Okay, let's talk about data modeling. It's super important for backend development because it essentially dictates how all your information will be organized and stored in the database. We start with a broad picture: what kind of data do we need? Then we get more detailed, figuring out exactly how everything connects. Finally, we translate that into a specific structure that works with our chosen database system, like SQL or something else. Thinking about these different levels helps ensure you have a solid foundation for your backend. Let's talk about OR, and they're seriously awesome tools for backend developers. Basically, they help you communicate with your database using code instead of complex SQL queries. There are a bunch out there, like SQLize for Node.js, SQL Alchemy in Python, Hibernate for Java, and Prisma, which is gaining huge popularity due to its modern approach. Each one has its strengths, but the main goal is always the same: to make working with your database easier and more efficient. Okay, let's talk about keeping our data safe when multiple users are accessing it at once. We're looking at database transactions and locking. Think of them like a set of instructions that either all get completed or none of them do. It's like an atomic operation: everything or nothing. These transactions adhere to something called ACID properties: atomicity, consistency, isolation, and durability. Atomicity means all parts succeed together, consistency keeps our rules intact, isolation makes sure concurrent operations don't mess things up, and durability ensures our changes stick around. And to make sure that isolation works properly, databases use locking mechanisms like shared locks for reading and exclusive locks for writing. Choosing the right locking strategy is key to balancing performance with data integrity. Okay, let's talk about connection pooling. Think of it like this: every time your application needs to talk to the database, it has to establish a brand new connection. That takes some serious effort. But what if we could avoid that constant setup and takedown? Connection pooling is the answer. It's essentially a pool of pre-built connections ready to go. When your app requests one, it just grabs one from the pool instead of building a whole new one. And when it's done, it puts it back in the pool for someone else to use. This saves an asterisk of time and resources, making your backend perform better and scale up as needed. Okay, let's talk about distributed systems. Basically, they're like a team of computers working together to achieve one goal. Instead of having everything crammed onto just one machine, you spread it out across several independent ones. This approach allows us to handle huge amounts of data and user scaling up as needed. It also means if one part of the system goes down, the others can keep running, making things more reliable and available. Finally, distributing tasks lets us process information much faster. Okay, let's talk about load balancing. It's a super important part of building robust backend systems. Basically, it's how we distribute incoming traffic across multiple servers instead of relying on just one. This prevents any single server from getting overwhelmed and keeps your application running smoothly even during peak times. We have a few different types of load balancers you can go with: dedicated hardware appliances, software solutions like Nginx or HA Proxy, or leverage managed cloud services if that's more your style. And when it comes to choosing an algorithm for distributing traffic, things like round-robin, lease connections, and IP hash all have their strengths depending on what you're trying to achieve. Okay, let's talk about how we can seriously speed up our backends. We're going to look at some key caching strategies. First up is a memory caching. Think of it like a super fast notepad right inside your server's memory. It's perfect for things users come back to often, like their session data or frequently requested API responses. I've included a simple JavaScript snippet to illustrate how you might use this. Next, we have content delivery networks, or CDNs. These are like having copies of your static assets images, CSS, and JavaScript spread out across the globe. This means users get content from the server closest to them, drastically reducing loading times. Finally, let's look at reverse proxies. They sit in front of our servers, handling requests before they reach the actual application. They are like gatekeepers, balancing load, providing security, and even caching responses to make everything run smoother. Okay, let's talk about keeping our backend caches fresh. Caching is awesome for speed, but if the data in the cache isn't current, it can be really frustrating for users. We've got a few key strategies we can use. First up is TTL time to live. This just means setting an expiration time for each cached item. Then there's write-through caching, where updates happen immediately to both the cache and the database, ensuring consistency. Write-back caches are faster for writes but have a risk of data loss if something goes wrong in between. Finally, we need to prevent cache stampedes. Imagine everyone trying to fetch the same data at once after it expires. Techniques like LOU least recently used can help us handle it gracefully. Okay, let's talk about microservices. Think of it like this: instead of one huge, complicated program, we break things down into smaller, self-contained pieces, individual services. These services are completely independent of each other, meaning you can update or scale just one service without affecting the others. Each service focuses on a specific area of the application, like product information, user accounts, or payment processing. This approach gives teams more flexibility and control, making it easier to build, deploy, and maintain complex applications. It also provides better resilience. If one part fails, the whole thing doesn't necessarily crash. Let's talk about how backend applications are structured. We often start with a monolithic architecture, basically one big program, all bundled together. That's simple to build initially, but it gets tricky when you need to scale or update things quickly. Then there's microservices, which breaks down your application into smaller, independent pieces that talk to each other. Think of it like a team of specialists, each focused on one specific task. Finally, we have serverless, where the cloud provider takes care of all the servers for you, and you just write your code and deploy it when something happens. It can be really cost-effective and easy to scale, but there are some trade-offs to consider. Okay, let's dive into service discovery and API gateways. They are crucial for building robust microservice architectures. Service discovery is like a dynamic phone book that helps services automatically find each other without needing to be hard-coded. Think of it as a way to keep track of all your moving parts. An API gateway acts as the front door for your application, handling everything from authentication and authorization to routing requests to the correct backend service, basically simplifying things for the user. We use tools like Console or EPT for service discovery, and Con or AWS API Gateway are popular choices for gateways. Let's talk about how different backend services need to communicate with each other. Think of an application as a bunch of specialized teams working together. That's what these services are like. We have a few main ways they can talk. REST, which is really common and straightforward using HTTP requests, gRPC, which is super fast using protocol buffers for data, and then message queues. Think of it like sending letters through the mail. These allow teams to work independently without needing to constantly call each other directly. Each method has its own strengths and weaknesses, so choosing the right one depends on the specific needs of your application. Let's talk about message brokers. They're like the unsung heroes behind many scalable applications. Essentially, these are software systems that help different parts of your app communicate with each other without being directly connected. Think of it as a post office for your services. We have a few main players: RabbitMQ, which is super flexible and easy to get started with; Kafka, built for handling massive amounts of streaming data, great for things like tracking events or analyzing real-time information; and ActiveMQ, which really shines when you need GMS compliance and are focusing on enterprise features. Each one has its strengths and weaknesses, so it's important to choose the best fit for your project's specific requirements. Choosing the right broker is a big decision. Okay, so let's talk about how event-driven architecture is changing the game in backend development. Instead of a system constantly waiting for requests and then sending responses back, we're building systems that react to things happening, events. Think of it like this: an event producer, maybe a service handling user logins, generates an account-created event when someone signs up. This event is sent to a central hub called an event bus or broker, which then delivers the event to any other services that need to know about it. For example, a service might listen for this account-created event and automatically update your user profile database. It's all about decoupling different parts of your system so they can react independently, making things more flexible and scalable. Okay, let's talk about asynchronous programming. Think of it like this: in a regular program, if you're waiting for something to load from the internet, your entire application just sits there doing nothing until it's done. That's not ideal. Asynchronous programming lets your app keep working on other things while it's busy with that long-running task, making it much more responsive and efficient. The main tools we'll be using are promises and async/await. They're really powerful ways to manage these kinds of situations. Okay, let's talk about job queues and task scheduling. These are super important for building really solid backend systems. Think of a job queue as a waiting line where tasks go when they need to be done. A task scheduler is like the person who looks at that line and hands jobs off to workers. Message brokers, like RabbitMQ or Kafka, help make sure all these different parts of the system can talk to each other smoothly. The main benefits are you can handle a lot more requests, things don't break so easily if one part fails, and it's easier to change things around later on because everything is nicely separated. Okay, let's talk about file storage, a really important part of backend development. When it comes to storing data, we have several options. First up is local storage, like your computer's hard drive. This is super fast for small amounts of data, but it can be tricky to scale if you suddenly need a lot more space or if something goes wrong with your server. Next, we have cloud storage. Think services like AWS S3 or Google Cloud Storage. These are fantastic because they are incredibly scalable and reliable, plus they often handle backups for you. Finally, let's not forget content delivery networks, or CDNs. They're basically a network of servers that distribute your website's files closer to users around the world, making things load much faster, especially important for images and videos. Okay, let's talk about handling files on the back end. It's a pretty important part of many web apps. First, security is key. You want to make sure you aren't accidentally accepting harmful files onto your server. Then there's validation, making sure the file type and size are what you expect. You'll also need to figure out where you're going to store these files, whether it's on a local drive or perhaps in cloud storage like AWS S3. Finally, once they're uploaded, you might have some processing to do, maybe resizing images or converting file formats. And don't forget to store details about the file itself in your database. Okay, let's talk about server frameworks. These are like the engines that power your backend applications. We've got a few popular choices here. Express.js, which is super popular for JavaScript developers. Fast API, built with Python and known for its speed. Spring Boot, a heavyweight but incredibly powerful choice for Java projects. Django, really good if you want to build web apps quickly. Flask, a smaller, more nimble option also in Python. And finally, Netcore, especially strong if you're working with C#. Okay, let's talk about middleware. Basically, it's a piece of code that sits in the middle of your web application flow, handling requests before they get to your main business logic. It's like a gatekeeper, ensuring everything runs smoothly. Middleware can do all sorts of things, checking if a user is logged in, recording what's happening for debugging, or even modifying data before it's sent back to the client. Think of it as adding extra layers of functionality without changing your core app code significantly. I've shown you a little snippet here in Python. This function checks for admin access and returns an unauthorized error if needed. It's all about making things secure, manageable, and efficient. Okay, let's talk about dependency injection, a really powerful idea for building robust backend applications. Basically, instead of a class asterisk making asterisk its own tools or resources it needs to do its job, we give those tools to the class. Think of it like this: you wouldn't build your own car engine, you'd get one from a supplier. Dependency injection does something similar for our code. We define clear interfaces that describe what dependencies are needed, then provide concrete implementations and pass them in when a component needs them. This makes things much more flexible, easier to test, and ultimately leads to cleaner, more maintainable code. Okay, let's talk about how middleware can really level up our backend systems. We're specifically focusing on two key areas: authentication and logging. Think of middleware as a gatekeeper. It sits between the incoming request and your actual route handlers. For authentication, this means verifying that the user asterisk is asterisk who they claim to be, often using things like JWT or session cookies. We can even build in custom rules for authorization. Now, logging middleware is all about capturing information as requests come and go. It records details like the URL being accessed, the HTTP method used. Response codes everything we need to understand what's happening under the hood. By strategically inserting these pieces of middleware, we create a more secure and easier to debug application. Okay, let's talk about environment variables. They are really important part of backend development. Basically, they're like secret codes that tell your application how to behave, things it needs to know like database passwords or API keys. Hard-coding these directly into your code is a massive security risk and makes moving between different environments like development versus production a nightmare. We'll cover what they are, how you set them up, and some common ways developers handle them, including using frameworks, deployment platforms, and even simple env files for local development. Okay, let's talk about logging in backend development, specifically structured logging and log rotation. Structured logging is all about adding meaningful data to your logs, like the level of severity, a timestamp, which service was involved, what operation happened, and even a descriptive message. Think of it as creating standardized reports instead of just raw text. This makes searching and analyzing logs *way easier. Now, as your application grows, those logs can quickly take up a ton of space. That's where log rotation comes in. It's essentially a system for regularly archiving or deleting older logs to prevent them from consuming all your disk space. You can rotate daily, weekly, or even based on file size. Okay, so as backend developers, it's crucial to know if our systems are running smoothly. We use a really effective set of tools: the Prometheus, Grafana, and ELK stack. Prometheus is like a constant observer, collecting data about things like how much CPU and memory we're using and how quickly requests are taken. Then, Grafana takes that data and turns it into easy-to-understand charts and graphs so we can spot any problems. Finally, the ELK stack, Elasticsearch, Logstash, and Kibana helps us analyze our logs and find out why things might be going wrong. It's like having a detective for our backend. Okay, so let's talk about keeping a close eye on your backend, specifically through metrics and health checks. Think of it like a dashboard for your application. We want to track key things like how long requests are taking, what percentage of them are failing, and even how much CPU and memory you're using. Beyond just fixing problems when they happen, proactive monitoring is vital. And that's where health checks come in. These are simple endpoints, little tests we create in our code to automatically verify the core functionality is still working correctly. It's a really valuable way to get alerted quickly if something goes wrong before it impacts your users. Okay, let's talk about CI/CD pipelines. They're absolutely essential in modern backend development. Think of it like an automated assembly line for your code. Continuous integration focuses on merging those changes frequently and automatically running tests to catch problems before they become big issues. Then comes continuous delivery, where the code is prepared for release, often through staging environments. And finally, continuous deployment goes a step further and automatically releases that ready-to-go code straight into production. It's all about delivering value faster and more reliably. Okay, so Git is really important for backend development, basically like having a time machine for your code. Think of it as a way to keep track of all those changes you make while building something. We've got repositories. These are just folders that hold everything. Then we have commits, which are snapshots of the project at specific moments. And finally, pushing is how you share those changes with others on platforms like GitHub or GitLab. Okay, so let's talk about containerization with Docker. It's a huge game changer for backend developers. Basically, Docker creates self-contained packages called containers that bundle your application *and everything it needs to run: libraries, dependencies, runtime environments, the whole shebang. This means you can move your app seamlessly between different machines without worrying about compatibility issues or setup headaches. It's like shipping an app in a standardized box, guaranteeing it'll work the same way everywhere. The main benefits are portability, runs anywhere, isolation, keeping things separate and secure, scalability, easily running multiple copies, and reproducibility, consistent deployments every time. Okay, let's talk about Docker Compose. It's basically a tool that makes it super easy to run complex applications made up of multiple containers. Think of it like an orchestra conductor. It tells all the different parts of your app how to work together seamlessly. You define everything you need in a simple YAML file, and then with one command, you can launch your entire application stack. It handles networking and data persistence, so you don't have to worry about the details. Let's talk about Kubernetes, or Keats. It's a really powerful tool for managing containerized applications. Think of it as the conductor of an orchestra, ensuring all your containers are working together smoothly. At its core, a pod is like a single box containing one or more containers that share resources. Deployments tell Kubernetes what state you want, how many copies of your application to run, and if something fails, Keats will automatically fix it. Services provide a consistent way to access your app, even as the underlying pods change. Kubernetes really shines when you need to scale up or down quickly, or maintain high availability for your backend services. Okay, let's talk about infrastructure as code, We're going to explore how we can manage our cloud infrastructure using code instead of manually configuring everything. Terraform is a really powerful tool that works with multiple cloud providers like AWS, Azure, and Google Cloud, making it super flexible. CloudFormation is mainly focused on Amazon Web Services, but it's still a great option if your environment is predominantly AWS. Essentially, both tools let us describe what our infrastructure should look like, rather than how to build it, which helps with consistency and automation. Okay, so as a backend developer, you'll hear a lot about cloud services these days, and for good reason. We're talking about AWS, Azure, and GCP. They all offer massive amounts of computing power and storage, but they each have slightly different strengths and target different use cases. Think of AWS as the most established player with a huge range of options. It's great for everything from building scalable web applications to storing data securely. Azure is really strong when you're already using Microsoft technologies or need a hybrid cloud setup. And GCP? Well, Google excels at data analytics and machine learning, making it a fantastic choice if you're working on those kinds of projects. There isn't necessarily a best, it's all about picking the one that fits your project best. Okay, let's talk about protecting your backend API, specifically with rate limiting and throttling. These are super important for preventing abuse like denial of service attacks or bots from overloading your system. Rate limits simply define how many requests a client can make in a certain amount of time, kind of like a restaurant only serving so many customers per hour. Why do we need it? Well, it helps stop malicious activity and ensures everyone gets fair access to your API. We have different approaches, like the token bucket or leaky bucket algorithms. And crucially, throttling is different from rate limiting. It's about slowing down requests instead of blocking them entirely. Think of it as a way to manage resources effectively without completely cutting off users. Okay, let's talk about keeping your backend safe. Security is a huge part of being a great backend developer. We really need to focus on a few key areas: authentication and authorization, which means making sure users are who they say they are and that they only have access to what they need. Then there's input validation. It's absolutely critical never to assume data is safe just because a user provided it. Finally, we need to encrypt our sensitive information when it's stored and perform regular audits to spot any potential weaknesses. Okay, let's talk about SQL injection. It's a really important topic for backend developers. Basically, it's when someone tricks your database into doing something it shouldn't, like revealing sensitive information or changing data without you knowing. It happens when user input isn't properly checked before being used in an SQL query. Imagine someone sneaking malicious code into a command to get around security measures. That's kind of what SQL injection is all about. We'll look at how it works, and most importantly how to stop it using techniques like parameterized queries, which are super helpful for keeping your database safe. Okay, so let's talk about XSS and how it plays into backend development. Basically, XSS is a way for attackers to sneak malicious scripts onto websites. Think of it like planting a tiny bomb that can cause all sorts of trouble. When we're dealing with API, which are the core of many web apps, this becomes especially important. The good news is there are ways to protect yourself. The main thing to remember is robust input validation. Always make sure you're checking and cleaning any data coming into your API. And equally important is output encoding before sending data back from the API, especially if it's going to be used in a web page or application. You need to encode it properly. Finally, using content security policy can really help limit where scripts can run. Let's look at an example. Imagine an API that displays user comments without proper sanitization. A sneaky attacker could inject code that leads users to fake login pages. Okay, let's talk about a really important security topic for backend developers: cross-site request forgery, or CSRF. Basically, it's a sneaky attack where someone tricks your website into performing actions without the user even realizing it. Imagine an attacker creates a link that looks like a harmless email. When you click it, it automatically sends a request to your site, changing something without your permission. To prevent this, we use techniques like synchronizer tokens, which are unique codes added to forms and requests, and we can also leverage same-site cookies. It's definitely worth keeping an eye on and regularly checking for vulnerabilities as part of your security routine. Okay, let's dive into securing our backend applications. We'll start with something relatively straightforward: security headers. Think of these as quick fixes that add an extra layer of defense against common threats. They're easy to implement and can make a real difference. Some key ones include HSTS, which forces HTTPS X-frame options to prevent clickjacking, and X-content type options to stop potential MIME sniffing issues. Now, Content Security Policy, or CSP, is a more advanced technique. It's like creating a whitelist telling the browser exactly where it's allowed to load resources from. This significantly reduces the risk of cross-site scripting attacks. I recommend using a CSP evaluator tool to make sure your policy is properly configured and not blocking legitimate functionality. Okay, let's talk about how we check our backend code, specifically static and dynamic analysis. Static analysis is like a really thorough review of your code before you even run it. It's essentially a spell checker that looks for potential problems, style issues, and security weaknesses. Tools like SonarQuebec can help with this. Now, dynamic analysis happens while the code is actually running. Think of it as testing. We're making sure everything works correctly when it's in action. JUnit and Makito are common tools used for this. It's all about verifying that your backend does what you expect it to do. Okay, let's dive into securing your backend. HTTPS is absolutely crucial for protecting user data. It's essentially a digital lock on all communication between your website and its users. We use two main technologies here, SSL and TLS. Think of SSL as the older version and TLS as the more robust and secure evolution. SSL/TLS work by scrambling up the data using secret keys before it travels across the internet, so if someone tries to intercept it, they'll just see gibberish. The server shows a digital certificate proving who it is, ensuring that you're actually talking to the real website. It protects your users, and frankly, it's a best practice for any backend project. Okay, so let's talk about API versioning. As backend developers, we all know that API change and those changes can sometimes be tricky for other applications relying on them. Versioning is essentially a way to manage these updates without breaking things for your existing users. We've got a few different ways to do it. One common approach is simply adding version numbers to the URL itself, like /fun/users. Alternatively, you could use headers or query parameters. The key takeaway is that thoughtful versioning helps maintain backward compatibility, making transitions smoother and reducing the risk of problems for your clients. Okay, let's talk about GraphQL. It's a really different way to build API compared to the traditional REST approach. Instead of relying on fixed data structures and multiple endpoints, with GraphQL you essentially ask for exactly what you need. It's like telling the server, give me just these specific ingredients, instead of getting an entire pre-made meal. The core ideas are queries, which are used to get data, mutations which are used to change things in the server, and a schema that acts as a blueprint for your API. Okay, let's talk about gRPC and protobuf. They are a powerful combination for modern backend development. gRPC is essentially a way to build really fast and efficient API, especially when you're dealing with lots of data moving between different services. It uses protocol buffers as its core, which are like super efficient data serialization formats. Think of protobuf as a very structured way to package up your information before sending it along. With gRPC, you define your data structure using what's called a protofile, and then the tools automatically generate code for all the languages you want to use, making development much smoother. It's fantastic for microservices architectures where speed and reliability are critical. Okay, so let's talk about static sites. Basically, they're websites that are built entirely of pre-existing files like HTML, CSS, and some JavaScript. No complicated server-side logic here. They're super simple to set up and perfect for things like personal blogs or portfolio websites where your content doesn't change all the time. It works by someone requesting a web page, and a web server just delivers the ready-made file directly to the browser. Okay, let's dive into how backend services talk to each other. Often you don't want one service constantly calling another. That can create problems with scaling and overall design. We use two main approaches, webhooks and callbacks. A webhook is like a push notification. When something important happens on one service, it automatically sends an update to another. Think of it as the provider telling the consumer, hey, this just happened. A callback, on the other hand, is like pulling information the receiving service checks in regularly to see if anything has changed. It's more of a constant check-in. Let's look at a quick comparison table. Webhooks are generally easier to set up and offer more real-time updates, while callbacks might be better when you don't need instant notifications. Okay, let's talk about reverse proxies and gateways. They're both important players in a well-designed backend architecture. Think of a reverse proxy as your server's bodyguard, hiding its details from the outside world and handling security concerns like authentication. It can also make things faster by caching frequently requested content. Now, a gateway is more specialized. It acts like a translator or router, ensuring different systems can communicate with each other, especially if they use completely different protocols, like translating an HTTP request into something another service understands. The main difference: proxies focus on security and performance enhancements, while gateways handle protocol conversions and routing between services. Okay, let's talk about designing API that are really easy to understand and build upon. We're going to focus on something called resource-oriented design. Think of your data as individual things like users, products, or orders. Each one is a resource. The key idea is to treat these resources separately with specific actions we can perform on them. We use standard HTTP methods like get to retrieve information, post to create new items, put or patch to update existing ones, and delete to remove them. Then, we build our URL, those web addresses, to clearly show what resource we're talking about. For example, /users/123 would be the specific URL for user number 123. It's all about making things predictable and straightforward. Okay, let's dive into database migrations and seeding, super important stuff for any backend developer. Migrations are like blueprints that tell your database how to change over time. They handle evolving requirements and make sure everything is consistent across different environments. They work by defining a schema change in a file, then running that file with your database tool. And always keep those migrations under version control, so you can easily roll back if something goes wrong. Now, seeding is a bit different. It's about actually adding data to the database. Think of it as populating your tables with initial information like users or products. It's not about changing the structure itself, it's just adding content. Essentially, migrations change **how* the database looks, while seeding changes what * it contains. It's a critical part of getting your app up and running smoothly. Okay, let's talk about data backups. It's a surprisingly important part of being a backend developer. Think of your application's data as the engine. If that engine breaks down, everything stops. So, we need to build in redundancy. That means regularly backing up your data, ideally, automatically and consistently. It's not enough just to back it up once. You want multiple copies stored in different places, including offsite. And crucially, you have to *test those backups regularly to make sure they actually work when you need them most. A solid disaster recovery plan will outline exactly how you'll get things back online after a problem. Okay, let's talk about how to handle mistakes in your backend code. It's really important because it directly impacts user experience and makes debugging much easier. We're going to cover why error handling is so crucial, like giving users helpful messages instead of confusing errors, and making it simpler to fix problems later on. Most frameworks have built-in ways to catch exceptions and return standard HTTP codes like 500 for internal server errors or 400 when something isn't quite right with the request. But you can do more than just send a generic "something went wrong" message. You can create custom error responses, which means providing structured data in JSON format to give developers even more context, and crafting user-friendly messages that explain what happened without technical jargon. And don't forget, always log detailed error information on your server for easier troubleshooting. Okay, let's talk about building backends that can actually grow with you. Scalable architecture is key. It's all about making sure your system doesn't break when more people start using it. We're talking about principles like keeping different parts of the system independent from each other, so if one part needs to be scaled up, it doesn't affect the others. Also, stateless services are great because they make scaling much easier. Think about dividing your big application into smaller, independent microservices, and don't forget about database sharding, spreading your data around to handle more load. Tools like message queues and containerization can really help with this too. Okay, let's talk about how we make our backends handle more traffic. As things get busier, we need to scale, basically add more power. We have two main ways to do this: horizontal scaling and vertical scaling. Horizontal scaling is like adding more lanes to a highway. You just clone your application and spread the load across multiple servers. This is great for handling huge spikes in demand and makes things really resilient because if one server goes down, others can pick up the slack. Vertical scaling, on the other hand, is like making an existing road wider. You beef up the resources of a single server, giving it more CPU power or memory. It's often easier to start with vertical scaling, but eventually you'll hit a limit. There's only so much you can squeeze into one machine. Okay, let's talk about keeping things consistent when multiple parts of your application are working together. Imagine a customer ordering something. You need to update inventory and process payment. Traditional transactions work great for one database, but not across systems. We've got the two-phase commit protocol, which is like a coordinator asking each service if it can commit. It's reliable, but can get tricky with failures. A more modern approach is called SOG, as they break down large transactions into smaller steps and roll back changes if something goes wrong along the way. It's a bit more complex to design, but provides much greater flexibility. Okay, let's talk about the CAP theorem, a really important concept when you're building distributed systems as a backend developer. It basically says that if you're working with multiple servers or nodes, you can only guarantee two of these three things: consistency, availability, and partition tolerance. Consistency means everyone sees the same information at the same time. Availability means every request gets a response, even if it's not always the most up-to-date. And partition tolerance is crucial. It's about your system staying running even when parts of the network go down. It's all about making smart choices about what you prioritize, because you can't have everything at once. Okay, let's talk about some key design patterns that are super important when you're building backends. First up, we have the singleton pattern. It makes sure you only ever get one instance of a particular class, perfect for things like global settings or shared resources. Then there's the factory pattern. It allows you to create objects without needing to know exactly which class they belong to. This is great when you're dealing with lots of different types of data. Next, we have the repository pattern. This acts as a shield between your application logic and how your data is stored. It hides all that messy storage detail away. Finally, we've got the observer pattern. It creates relationships between objects so that when one changes, everyone who's watching gets automatically notified and updated. These patterns can really help you build more flexible and maintainable code. Hey everyone, let's talk about keeping our backend code in tip-top shape. It's not just about making it work *, it's about making sure it stays working well, and that we can easily make changes down the line. Clean code is super important. Think of it like a well-organized toolbox. Everything has its place, and you can find what you need quickly. We'll cover some key principles like readability, maintainability, and testability, and then dive into some handy refactoring techniques. Refactoring is basically improving our code without changing how it looks from the outside. Techniques like extracting methods, breaking big functions down into smaller ones, renaming variables to be clear, and eliminating duplicated code are all great ways to keep things tidy. This example shows how simple calculation can become much more readable and easier to maintain when refactored. And remember, this isn't a one-time thing. Continuous refinement is key to preventing technical debt. Okay, let's talk about designing good backends. We want systems that are easy to understand, maintain, and grow with. First up is Solid. It's a set of principles for object-oriented design. Basically, it encourages you to break down your code into smaller, more manageable pieces, minimizing dependencies between them. Next, we have DIY. Don't repeat yourself. This is a huge one. It means avoiding duplicating code, which makes debugging and future changes much easier. Then there's keep it simple, stupid. Aim for the simplest solution that works, and definitely avoid over-engineering. Finally, you ain't gonna need to resist adding features you might need in the future until they actually are required. Focus on what you need now, not what you think you might need later. Okay, let's talk about unit testing, a really crucial part of backend development. Basically, it's like checking that each little piece of your code, like functions and modules, works exactly as you expect. Why bother? Well, catching bugs early saves time and headaches later on. There are several popular frameworks out there for different languages. JUnit is the go-to for Java, PyTest is super easy to use in Python, Mocha integrates well with JavaScript testing libraries, and Jest from Facebook offers really good performance, especially if you're working with React. Okay, let's talk about ensuring your backend application is rock solid. We'll be looking at two key types of testing, integration and end-to-end. Integration testing is all about making sure that the different parts of your system, like your order service and your payment processing, are communicating correctly with each other. We do this by essentially creating fake versions of things outside your core code, so you can focus on how those components interact. Now, end-to-end testing goes a step further. It's like putting on the user's shoes and walking through the entire application process. We use automation tools to simulate how a real user would actually navigate and complete tasks, think placing an order from start to finish. Both are super important for catching bugs that might not be obvious otherwise, so understanding the differences is key. Okay, so when we're testing backend code, it can sometimes be tricky because our functions often rely on external services or complex databases. That's where mocking and stubbing come in. Think of stubbing as a simple placeholder, like giving a function a canned response. It's great for quickly testing if your code works with that dependency. Mocking, on the other hand, is a bit more sophisticated. It creates a whole simulation of the dependency so you can actually check how your code interacts with it, whether it calls the right methods, passes the correct arguments, and gets the expected results. They help us isolate components, speed up tests, and have much greater control over our testing environment. Okay, let's talk about load testing and performance benchmarking, really important stuff for any backend developer. Basically, you want to make sure your systems can handle a realistic number of users without slowing down or crashing. If your application isn't built to handle the traffic it receives, it will lead to poor user experiences and ultimately hurt your business. There are several tools available like JMeter, LoadView, Gatling, and K6. Each has its strengths. The process usually involves defining what you want to test, how many users, what they are asking for, and any data involved. Then, you set up the tool, run the tests, and carefully watch metrics like response time, how much data is being processed, throughput, and error rates. Finally, you analyze the results to find anything that's causing performance problems. Okay, let's talk about code review. It's absolutely vital for building solid, maintainable backend systems. First, before you even start looking at the code itself, take a step back and make sure you understand why we're building this feature in the first place. What problem are we solving? Next, when reviewing, concentrate on making the code as clear and easy to read as possible. Good variable names, helpful comments, consistent formatting. It all adds up. Then, scan for potential bugs. Do we have proper error handling? Are we covering those tricky edge cases? And is the code secure enough? Don't forget about testing too. Make sure you're reviewing alongside unit tests. Finally, create a checklist to ensure everyone on your team follows the same best practices. Okay, let's dive into Agile and Scrum. They're super important if you're a backend developer. Agile is really just an approach to building software that focuses on working closely with clients and adapting quickly as things change. Scrum is a specific way of using those Agile principles, like a recipe for how your team works. It has key roles: a product owner who knows what needs to be built, a Scrum Master who keeps things running smoothly, and the development team that actually does the coding. They work in short bursts called sprints, usually around 2 or 3 weeks long. During each sprint, they plan what they'll do, have quick daily meetings to check in, show off their progress, and then reflect on how it went to improve for next time. Okay, let's talk about something super important for backend developers: documentation. Why does it matter? Well, good documentation makes our code much easier to understand and maintain. It's like a roadmap for anyone who needs to work on the project, whether it's another developer joining the team or even you coming back to it months later. We want to keep things consistent, so think about using a style guide for naming conventions and formatting. And remember, write clearly and simply, assuming your reader knows nothing about the specific code. It's also crucial that documentation is accurate and up to date. Outdated docs are really frustrating. Finally, let's explore some tools. Markdown is great for readmes and API docs. Swagger/OpenAPI is fantastic for REST API, and JSDoc or Doxygen work well for various languages. Documenting effectively truly does pay off in the long run. Let's talk about how we get our backend changes live without causing any problems. When deploying, we want to minimize downtime and risks. There are a few powerful strategies that can help us achieve this. First up is blue-green deployment. It's like having 2 identical environments, but you switch traffic over to the new version after testing it out. Next, we have canary releases, which means rolling changes to just a small percentage of users initially to get early feedback. Finally, there's rolling updates, where we gradually replace older versions with newer ones. Each method has its pros and cons, so choosing the right one depends on your specific needs. Always remember, thorough testing is key. Okay, so after you've built your awesome backend code, the real work starts: keeping it running smoothly. That's where continuous monitoring and feedback loops come in. Think of it like this: you need to constantly check on your system, not just once and forget about it. Monitoring lets you spot problems early, like slower response times or errors, before they really affect users. Then, by analyzing the data you collect, you can find why those issues are happening. Once you know what's going wrong, you can fix it. And of course, after making a change, you need to measure if it actually helped, because sometimes improvements can create new problems too. It's an ongoing cycle of checking, understanding, fixing, and measuring. Okay, so as your backend application becomes more popular, you'll eventually need to think about how to handle increasing amounts of data. That's where database replication and sharding come in. Replication is all about creating copies of your data across different servers, kind of like having multiple backups that are always available if one goes down. You can have a main server handling writes, and then automatically copy those changes to other servers to ensure business continuity. Then there's sharding, which is a bigger strategy for scaling. Sharding breaks up your entire database into smaller chunks called shards, spread across multiple servers. Think of it like dividing a giant library into smaller branches. You can handle more visitors and requests without overwhelming any one location. Choosing the right shard key and considering data locality are crucial to making sharding work effectively. Okay, let's talk about multi-tenancy. It's a really common pattern in backend development. Essentially, it means you have one single application instance serving many different customers or organizations. Imagine it like an apartment building. The building itself is shared, but each tenant gets their own private space and doesn't interfere with others. The core idea is to share infrastructure while making sure each tenant's data stays completely separate. We need ways to identify which tenant a request belongs to, often through things like API keys or unique identifiers. There are a few different architectural approaches, from having dedicated databases for each tenant all the way to sharing a single database with careful data segregation strategies. Want to dive deeper into any of these? Okay, let's talk about how to deal with really big files when you're building a backend. Traditional ways of loading everything into memory just don't cut it. It'll eat up all your resources and slow things down significantly. That's where streams come in. Streams allow us to process the file piece by piece, avoiding huge memory burdens. It's like eating a giant pizza slice by slice instead of trying to swallow the whole thing at once. We'll cover why they're important, what key concepts you should know like readable and writable streams, and even take a quick peek at an example in Node.js demonstrating how it works. Basically, mastering file streams is a huge step towards building scalable and reliable backend systems. Let's talk about making your backend run smoother seriously fast. First, we need to focus on our databases. That means optimizing those queries and building smart indexes. Then, caching is your best friend. Think of it like a super fast shortcut for frequently used data. Next up, let's dig into the code itself with profiling tools to find any bottlenecks that are slowing things down. Finally, load balancing ensures no single server gets overwhelmed. Spreading the work around evenly keeps everything running efficiently. Okay, let's talk about keeping things on schedule in a world of servers. When you have multiple computers all working together in a distributed system like an online game or a banking application, it's absolutely vital that they all know the same time. If one server thinks it's 2:0 p.m. while another thinks it's 2:03 p.m., things can get really messy. That difference is called clock skew, and it's a major headache for developers. We use protocols like NTP Network Time Protocol, which is like a chain of timekeepers helping to spread accurate time around. For super precise timing, there's PTP, the Precision Time Protocol, that can often use special hardware. And then there are logical clocks. These help us track events across different computers without necessarily agreeing on an exact moment in time. The key things to remember when choosing a method are accuracy: how precise does it need to be? Latency: how long does it take for the changes to propagate? And fault tolerance, meaning what happens if one of those timekeepers goes down. Okay, let's talk about feature flags. They are a super handy tool in backend development. Think of them like secret switches you can flip to control which parts of your app are active. Basically, you wrap specific code blocks inside an if statement that checks the state of the flag. It's great because it reduces the risk when deploying new features. You don't have to release everything at once. You can roll them out gradually, run a /b tests to see what users like best, and even target specific groups with certain features. Let's talk about keeping your backend applications running smoothly, especially when you're making updates. Downtime can be a huge problem for users and your business. That's where zero downtime deployments come in. Essentially, it's about updating your application without any interruptions to service. There are several techniques you can use, like rolling updates, when new versions of your app are gradually replaced, or blue/green deployments, which involve running two identical environments, one live and one updated. And for a really cautious approach, consider canary releases, deploying the changes to just a small group of users first, so you can monitor things before making it available to everyone. It's all about ensuring continuous availability. Let's talk about keeping those sensitive details safe. Managing application secrets is super important for any backend project. We'll be looking at two popular options, AWS Secrets Manager and HashiCorp Vault. Both help us store things like database passwords and API keys securely, preventing them from accidentally being exposed in our code or configuration files. AWS Secrets Manager is a fully managed service by Amazon. It's really easy to integrate with other services they offer. And Vault is an open source option that's incredibly flexible and allows you to manage secrets across different environments. When making your decision, think about how easy it is to use, what resources it needs, and of course, the specific security needs of your team. Let's talk about connecting your backend to the wider world through API. Think of them as bridges. They allow your application to chat with other services and add powerful features without you having to build everything yourself. There are tons of reasons to integrate, from saving development time to accessing specialized data like maps or payment processing. You'll encounter different API types, but REST is a really popular choice. Authentication is key here. It's how your application proves who it is and what it's allowed to do. Popular providers like Stripe handle payments for you, while services like Twilio let you send SMS messages or make voice calls. The possibilities are endless. I've included a quick JavaScript example showing how to integrate with Stripe, but remember, always keep your API keys safe. Okay, let's talk about keeping user data safe and sound. As a backend developer, you're often the gatekeeper of sensitive information, things like names, addresses, health records, or financial details. It's really important to understand that protecting this data isn't just about being ethical, it's also legally required. We'll look at two big players here: GDPR, which is a European regulation covering the privacy of EU citizens, and HIPAA, which focuses specifically on protecting health information in the United States. Your role as a backend developer involves making sure data is stored securely, that only authorized people can access it, and that you're only collecting what's absolutely necessary. And remember, compliance isn't a one-time thing. Staying up to date with regulations is key. Okay, so let's talk about what's going on in the world of backend development right now. We're seeing a huge shift away from big, complicated systems to more lightweight and flexible solutions. Serverless computing is becoming increasingly popular. It means you can run code without managing servers yourself. GraphQL is another big trend. It helps applications get exactly the data they need, making things much faster and more efficient. Then there's microservices architecture. Imagine breaking down a huge application into smaller, independent pieces. This makes updates and scaling way easier. And containerization with Docker ensures your code runs consistently everywhere. Finally, Go is a really powerful language for building backend systems. It's known for being super fast. Thank you for watching.